Today we are going to study chapter 20, and it is about electrical potential and capacitance. And the first thing we are going to study is electrical potential and the potential difference. Now, in order to study and understand potential and potential difference, we need to relate it to gravitational potential and gravitational potential energy. Now, if you remember that if on Earth there is an object which has a mass of m, it falls due to acceleration due to gravity, and this force due to which this object falls is given by mg. And at this height, if this height is h, then the gravitational potential energy is given by mgh. So this is gravitational potential energy. So it means that if this height is lesser, then the potential energy is small, and if this height is more, the potential energy will be more. Okay. Now another thing we need to understand is the work done in order to carry an object on Earth from one point to the other. Now suppose that on Earth there is an object which has a mass of m, and you apply some external force and you move this object to some other height, and let us say you've moved this object to this point, and suppose that initially the height is yi and the final height is yf, and the force we are using here is some external force. So let us say it is some external force which we are using to lift this object from one point to other. Okay, and displacement vector, now because we are moving in the upward direction, this will be the displacement vector in this case. So now if I have to find out the work done for this situation, now so the work done, you know that work done is given by force vector dot the displacement vector, whatever it is, like in this case it is delta r. So now this is the general definition I have written, but for this particular situation, work done by this force, so we say the work done by the external force will be equal to the external force dot displacement vector. Okay. Now these two forces, they are in the same direction. So if this is y and this is x axis, so f external will be j unit vector dot delta r j unit vector, and j dot j will be 1, so we'll get f external into delta r. Now in this case delta r will be final minus initial, and this force F external, this is such that its magnitude is equal to the gravitational force magnitude, which is equal to mg. So we've taken this external force such that it is equal to the gravitational force. So what we'll get here is mgyf minus mgyi. So now what is this quantity? This quantity is the potential energy, the gravitational potential energy. Okay, mgh, the height. So in this case the height is yi. So we can say that it is uf minus ui work done by external force, or work done by external force is equal to change in the potential energy, and this potential energy is the gravitational potential energy. So I use this subscript g for it. Okay. Now this was the work done by the external force. Okay. Now let's find out what is the work done by internal force. So by external force, what we found out is that the work done by the external force is equal to change in the gravitational potential energy. Okay. Now suppose that again you have this situation where there is this mass, okay, and it falls to this point, and due to the gravitational force, okay, and the displacement, now the displacement vector will be this, and this height is yi, and this height is yf. The height is fixed, it will not change, but the vector will change. So that is why I am using yi and yf here. You can also take it to be h1, h2. So it will remain h1, h2 irrespective of the vector. Okay. So that is why this height is still yi and this height is still yf. So in this situation, now this gravitational force is the internal force to this system. If this is your system, the gravitational force is internal force. Okay, so we say that the work done by the internal force, because gravitational force is internal force, so it will be the gravitational force dot the displacement. Okay, now again they are in the same direction, so what we'll get is Fg into delta R. Now what is gravitational force? It is mg, mass into gravity, into delta R. Now what should be delta R? yi minus yf. Okay, so it will be my yi minus yf. This is a little tricky part here, that this delta R in this situation is yi minus yf. Delta means change. We are moving from here to here. Okay, so this is final, this is initial, so it will be yi minus yf. So then we can say that it is mg yi minus mg yf. So it will be initial gravitational potential energy minus final gravitational potential energy. So the work done by internal force, and it is equal to delta U, will be equal to delta U. Okay. Now because here we are using this delta R, so delta U, but instead if suppose I write Fg vector dot displacement in a derivative, then it will be du. Okay, if it is a derivative here, we'll also have to take a derivative here, while if it is like in this case it is Fg vector dot delta R vector, so we are using, if delta, so we are using delta here, but if it is d derivative, we'll have to use du here. So from here what I wanted to explain is that for a force which is conservative force, the work done by the external force is equal to change in potential energy, and the work done by the internal force is equal to negative of change in the potential energy. Now because we're talking about the gravitational potential energy, so I use this symbol. Now so what we take from here is that the work done by external force is equal to delta U, and work done by the internal force is equal to minus delta U. Okay. Now this delta U depends. If we are taking a derivative, then we'll have to take a du. So now just keep this in mind and forget about all this. And now let's